My name's Giles Bill. I'm Head of Technology here at Myriad Minds. I've over 15 years experience in enterprise architecture and development, specifically on the Java platform for various J2EE projects. Most recently, I've become very interested in promoting best practices for Force.com platform projects and how we might implement the same kind of rigor and approach to development on that platform as we have traditionally in the J2EE space. I'm going to show you a couple of slides. We're going to talk about tooling, we're going to talk about source code management, we're then going to talk about the actual continuous integration server, how we fit it all together, and we're going to finish off with a demo of how we've implemented continuous integration here at Myriad Minds. Tooling. Each developer is going to need the Eclipse IDE. Now this is available on Windows, OS X, and Linux, so it's all covered. From my knowledge, the most recent version of the IDE won't work with a Force.com plugin. I use Ganymede personally. Now, in addition to that, you're going to need to install a plugin that is going to work with your source code management tool of choice. Here we use Subversion. We use the Subversion plugin. You're also going to need the Force.com Eclipse plugin. Now, this is so you can actually deploy your code to Salesforce and run your tests on Salesforce and generally interact with your Salesforce org. You may need the Force.com migration tool, which is essentially a set of Ant tasks that can be used to script a lot of the stuff that the plugin does. In addition, you might have requirements where you need to send data to your org at any time. Now, there are two ways you can do this. You can either use the Enterprise Order Partner WSDL and use the Metadata API, or you can script the data loader, or just use the data loader natively. For the purposes of this demo, we're not going to touch on that, but we will be touching on that in another webinar. So why do we need source code management? Well, no matter what size your project is, source code management is fundamentally necessary. It's all too easy to write over files, and once you have, you've lost them. Even in Salesforce, where you can save essentially you're saving your file onto the Salesforce server, the minute you write that back right over another file and you realise there's a mistake, that's it, you can't get your file back. This can cost both financially, can seriously damage your relationship with the client. Source code management enables you to version your files, you know your files are backed up. Now, some good examples of good SCMs are Subversion, CVS, ClearCase, and Visual Source Safe. Here at Myriad Minds, we use Subversion. So what are the benefits of source code management? Well, first and foremost, peace of mind. Once your source code management software is set up properly, and the developers are following guidelines, then you are safe in the knowledge that every file that you've committed is saved. It's saved as a version of it. The versions are tracked from the moment you initially commit a file. You can branch and you can tag development projects, so you can work simultaneously on various branches of a project. For instance, I might be working on a production fix while the next phase of development is going on simultaneously. We then merge these changes in at a later date. Traceability is that each developer will have his or her own login to the system, so we know who's committed what and when. Most source control tools will integrate with bug tracking and task management software. In our case, we use Subversion, which integrates very well with Jira for issue management. Integration with a continuous integration server itself. Most CI servers will provide hooks into all the popular source code management software. Once again, here we use Bamboo, which works very well with Subversion. We can also set up our source control repository to be backed up as frequently as possible. So we're safe and we know that our code is not only versioned but it's backed up. Source code management, how do we actually implement it? Well, as mentioned before, your source code management must have a compatible Eclipse plugin. We use Subversion, and Subversion provide a number of plugins that work with Eclipse. Eclipse then provides a kind of layer over the top of that plugin, which enables a developer to consistently interact with their source code management for adding files, committing files, updating files from their repository, merging files, viewing differences, rolling back versions. It's all consistently available regardless of whatever source control management software you're using. It's very important that developers follow procedures when using source control management, in that they must commit frequently and update code from the repository as frequently as possible. This ensures that code is committed and tested, and also that developers are aware of what other developers are working on. Now, source code management software doesn't have to be limited to just source code. It should be any project-related documentation should be under source control, unless it's available via some other means. For instance, here we use Confluence for all our documentation, so we know that it's going to be backed up. We know it's available through the web. So what is continuous integration? Well, I think Martin Fowler says it best. Continuous integration is a software development practice where members of a team integrate their work frequently. Usually each person integrates at least daily, leading to multiple integrations per day. Each integration is verified by an automated build, including tests to detect integration errors as quickly as possible. Many teams find that this approach leads to significantly reduced integration problems and allows a team to develop cohesive software more rapidly. Continuous integration is important for a number of reasons, and really any project that you're going to be able to commit code and you can write unit tests for should have some kind of continuous integration involved in the development lifecycle. For Force.com projects, I find that it's especially useful for number one, for ensuring that code actually compiles, because you cannot pick up a compilation error until the tests are run, and you cannot ensure that developers are going to run tests locally in their own sandboxes, because they have to do it manually. So really, to be able to pick up and run tests on every time code is committed is very important. It also ensures that there's a little thought that goes into writing unit tests, rather than simply trying to get the 75% coverage to get it into production. It promotes the writing of better unit tests, which is very important. I think it also promotes better quality of code, because you're thinking more about your unit tests and you're really thinking about the API you're writing and the quality of the code you're outputting. Continuous integration can also be used to incentivize developers, in that we can target developers who might be producing good tests, and we can use the metrics and the reporting tools in the integration server to maybe give them bonuses or isolate where there may be issues with developers consistently committing code that breaks tests. So how do we actually implement continuous integration? Well, I'll give you an example of how we do it here at Myriad Minds. We use Jira Studio, hosted from Atlassian. Now, Jira Studio comes with Jira for issue management, Confluence for documentation, Wiki, Subversion for source control, and Bamboo for continuous integration itself. Given that it's hosted, Bamboo actually uses a Amazon Web Services EC2 instance to actually run the build, which actually then runs a build via an Elastic agent against Salesforce. Bamboo essentially will poll the source control repository and look for recent commits. If there is one, a build will be triggered on the project, which in turn will instantiate an agent running on your EC2 instance, which will run against the sandbox which you've identified in your build script. results of the build, whether it fails, if it's a success, whatever it might be, are emailed to recipients. Recipients are associated with a build. So how does it actually all fit together? Well, we can see from this diagram that at stage 1, developer is working locally in their Eclipse against their local sandbox. Code will be written, saved, and hopefully tested locally by running the unit tests. We cannot guarantee that though. Once a developer is happy with what they've done, they'll commit their code to the repository. In our case, it's Subversion. The Bamboo server will then poll Subversion for changes for recent commits. If it finds that there's been a commit, it will now run the build against the Amazon EC2 instance. So it will start up an Elastic agent on the instance, which will run the build, which is a set of Ant scripts against the configured sandbox. Now, the sandbox itself will be configured as part of the build script. So Amazon knows which org and which sandbox within the org to hit based on the username, password, and the security key. Once the build is complete, the results are sent back to the developer via email, and the results could be that the build has failed, compilation error, or some tests have failed for whatever reason. It gives the developer time to check the tests against the latest code, ensure that other developers may not have broken the code, and to fix what needs to be fixed, recommit it, and repeat the cycle. So I think after all that theory, it's time to see it in action. So I'm going to show you the continuous integration cycle with a demo application set up with Bamboo running against Amazon.